All right, so let's see, 10.4, part 2. So what we're going to do here is we're going to apply, more or less for the rest of the chapter, but we're going to apply what we know about parametric equations to polar coordinates. So we know in polar coordinates that we have x equals r cosine theta and y equals r sine theta. And usually in polar coordinates, we're going to, our functions are going to be, our radius is going to be a function of theta. So I'm going to say r equals r of theta. So our polar equations are usually r equals something, something, something having to do with theta. So our polar coordinates are actually a set of parametric equations. So we can write that x equals r of theta cosine theta and y equals r of theta sine theta. So x and y are both functions of theta. So we have a set of parametric equations giving our x value and our y value, x coordinate and our y coordinate, in terms of theta. We plug in theta and we get our x's and y's. And so what we're going to do today is use what we developed with parametric equations to come up with the slope of the tangent line of a graph represented in polar coordinates. So our slope, dy dx, we decided was dy d theta over dx d theta. And we're going to do this operation with these sets of parametric equations. So we're going to take the derivative with respect to theta of r of theta sine theta over the derivative with respect to theta of r of theta cosine theta. So when we take this derivative, we're going to use the product rule, and we get a nice expression. We get r of theta cosine theta plus r prime theta sine theta in our numerator, and in the denominator we get minus r of theta sine theta plus r prime of theta cosine theta. And the reason that we wrote this all out, in general, to find our slope, we just do the derivative with respect to theta of our y and the derivative with respect to theta of our x, and do that as a fraction. I wrote this out for this way because we're going to use this also to talk about how we find the slope of the tangent line at the pole, because we get a special case there. All right, so there's our slope. We get this nice expression involving sines and cosines, and whatever our r of theta happens to be. One caution: the slope is dy dx. So I'm going to write this in red. The slope does not equal dr d theta. So please don't make that mistake. When we have r equals such and such, and it says find the slope of the tangent line, and often students want to say, oh, it's dr d theta. Slope is dy dx. Slope does not equal dr d theta. So what we're interested in is vertical and horizontal tangents. If dy d theta equals 0 and dx d theta is not equal to 0. So we're not moving up or down anymore as theta changes, but we are moving side to side. We get a horizontal tangent. And we're just going to switch these around. If dx d theta equals 0 and dy d theta is not 0, so we're not moving side to side anymore as theta changes, but we are moving up and down as theta changes, we get a vertical tangent. And with polar graphs, those can happen at multiple points. We can have multiple vertical and horizontal tangents on a polar graph. In fact, usually we have multiple vertical and horizontal tangents on a polar graph. All right, we're also interested in the tangent line at the pole. Well, if both of these are 0, dy d theta and dx d theta are both 0, I'm going to switch the page here. If those are both 0, we get an indeterminate form. We get 0 over 0. Usually when that happens, we're going to have a cusp or something happening at that particular point. If r of theta equals 0, so where are we if r of theta equals 0? We're at the pole. So r of theta is 0. This is the pole. So we're at the pole. And I'm going to say at theta equals alpha. Some theta value. And r prime of theta does not equal 0 at theta equals alpha. So we're saying that we're at the pole, but r prime is not 0. So let's go back here. We're at the pole. R of theta is 0. So these two terms drop out. And this term, r prime, is not 0. We get, well, and these are 0, so the r primes are going to cancel. So we get that the slope, dy dx, equals tangent of alpha at that particular theta value. So this tells us that's the slope of the tangent line. So that tells us that theta equals alpha is the tangent line at the pole. This should be a y. So this is how we're going to find our tangent lines at the pole. We look for where r theta equals 0. We check to see if r prime at that particular value is not 0. And if so, then whatever theta value that is going to be the tangent line at the pole. So theta equals alpha is a line through the origin. Tangent theta is the slope of that line. The tangent of theta is the slope of the tangent line. That's why that's called tangent.
There you go.
Tangent function gives us a slope. All right, so questions here. So this is our process for finding the tangent line at the pole. We check to see where r of theta is 0. We look at those theta values and see if r prime is not 0. And that's whatever angles those are going to be the tangent lines at our pole. If they're both 0, dy d theta, if they're both 0, we probably have a cusp or something similar. All right, so what I want to do is go through one example, because figuring out, going back here, figuring out these things, dy d theta equals 0, dx d theta equals 0, we're solving all these various trig equations. And if you remember, we were just talking about trig identities and how much we enjoyed them. Solving those trig equations can be interesting. It depends on what the identities are. We should know most of them.
Well, like all of just the normal routes.
We won't need half angle ones much. So let me grab a picture here.
Now, if I see a problem that has a trig identity in it, I'm just going to start having it.
All right.
It's just
Dylan, you can start now.
Oh, damn.
All right. We're going to, and I'm going to say this is 0 less than or equal to theta less than or equal to 2 pi. So we have this nice graph. F of theta is 2 plus 2 cosine theta, nice cardioid. And we want to find the slope of the tangent line at pi over 6. I'm going to say find 1. We want to find points with horizontal tangents. And I'm just going to underline points. When we want points, we want r theta, not just r, or not just theta. So we want to find points with horizontal tangents. We want the points with vertical tangents. And finally, we want points, the slope of the tangent line at the pole. So looking at this graph, how many points of horizontal tangency should we have? 2. How many points of vertical tangency should we have?
1.
3.
1, 2, 3.
Wait, why are those vertical tangents?
Sorry, 1, 2, 3.
Yes.
3 points. And what are we going to guess is happening at the pole? There's a cusp. So we should end up with no tangent lines at the pole. So our analysis, and what is our guess? What should our guess at theta equals pi over 6? What would you guess that's going to be? Well, it's got to be negative.
Negative pi over 6.
It's like
Negative something. It should be negative. All right.
we're going like a little bit less than -1.
So we have a nice cardioid. We need to write in parametric form. So our first step is write it in parametric form. So x, r cosine theta, this is r. So we get 2 plus 2 cosine theta times cosine theta. And y equals our sine theta. So we get 2 plus 2 cosine theta sine theta. So we can see already just the process of taking derivatives, because we get this nice r as a function of theta. We get it's already looking interesting.
Okay, interesting. That's a better word.
And now we have to find our derivatives. All right. So we have our parametric form. We find our derivatives, and then all of our other information comes from those derivatives. All right. So let's find these derivatives. dx d theta. When I take this derivative, I get -2 sine theta from that first term, and I get a from the second term, I get a plus. This is cosine squared plus 4 cosine theta times minus sine theta. And I'm going to rewrite this as, I'm going to change the order here, -4 sine theta cosine theta minus 2 sine theta. And we could rewrite this. It's going to be easier to calculate a little later. I'm going to rewrite this as -2 sine 2 theta minus 2 sine theta. Because 2 sine theta cosine theta is sine 2 theta. It'll be easier to calculate our slope with that than with this. A little easier. dy d theta. So that is this one. Got this scared away pretty quickly. Is yeah, she heard a D and a theta, and I'm done.
I think she just saw the trick.
Yeah, trig identity. She saw the look on all the students' faces and thought, "Oh my goodness, I'm leaving."
Oh, ouch.
All right, and here we have this nice product for our y value. So when I do dy d theta, I get we need to use the product rule. So I get a 2 sine theta times minus sine theta. I'm just writing everything out explicitly, plus cosine theta times cosine theta. And this is, we write it in a slightly more compact form, plus 2 times cosine squared theta minus sine squared theta. And that is also an identity. 2 cosine theta plus 2 cosine 2 theta.
Will we be given these identities on assessments? Or you recognize all these identities?
These we mostly we won't need these. Right. Well, I know them.
Of course.
All right. So now we can calculate our slope. Dy dx is dy d theta over dx d theta. So 2 cosine theta plus 2 cosine 2 theta over negative 2 sine 2 theta minus 2 sine theta. So there's our expression for our slope. This is a little nicer than this over, or yes, this over this.
If you left it out,
Little compact.
that's still correct.
It is still correct. I would not want to compute with
No, nobody wants to deal with it.
it. All right, so at pi over 6. dy dx is cosine pi over 6 plus cosine pi over 3 over sine pi over 6. Sorry, negative sine over minus sine pi over 3. Square root of 3 over 2 plus 1/2 minus 1/2 minus square root of 3 over 2. What is that? Negative 1.
Oh.
We knew that slope had to be negative, right? I can factor out a negative 1 here, and that's square root of 3 over 2 plus 1/2. Negative 1. So we knew the slope should be negative. Dylan, you said you thought it was close to something close to 1, right?
What do you think
I
of
said it
the
should be
identity?
less than, a little bit less than negative 1.
A little bit less than negative 1. Yeah. So you were close. Let's look at the pole. At the pole, so we're doing the last part first. At the pole, r equals 0. So to find those points, 2 plus 2 cosine theta equals 0. So cosine theta equals negative 1. To subtract 2, and so that we get theta equals pi. So that's the theta value at the pole. We need to check, is r prime of theta, r prime of pi, equal to 0 at the same time? So r prime of pi is minus 2 sine pi, which is equals 0. So we get no tangent line at the pole because both are 0. If r prime of pi had turned out not to be 0, then theta equals pi would be our tangent line at the pole. So we have that, we saw that cusp at the pole. All right, let's look at our horizontal tangents. A little early, but do we all know what a polar bear is?
Yeah.
Yeah, rectangular bear after coordinate transformation.
Lives at the pole.
Do you know what happens to polar bears when they sit on the ice for too long? They get Polaroids.
That's nonsense. Better edit that out.
Yeah, the pictures. I'm talking about the pictures. People take pictures of them. They get them really quickly. You guys are terrible. Horizontal tangents, dy d theta. Yeah, my wife was looking through a box the other day and she found a Polaroid camera that we have. But the film packs cost like $25 each. You buy them on eBay for more money. All right, for horizontal tangents, we need dy d theta equals 0. So we need to solve cosine theta plus cosine 2 theta equals 0. And this is another reason I wrote this, that cosine squared minus sine squared as cosine 2 theta, because it would be difficult to solve that equation in that form, but it's difficult to solve that equation in this form also.
No, it's pi.
What can we do here? We can't factor out a cosine, unfortunately, but I can factor if I say that cosine of 2 theta is, we used this one the other day, 2 cosine squared theta minus 1.
Of course, I remember that.
Why? Yeah.
It's just pi.
We can't just, we should look at the graph and like be like, that's probably what it is.
So when I substitute this in here, I get 2 cosine squared theta plus cosine theta minus 1 equals 0.
Can you like give us a video or something of all the quantities that we can?
Or just give us a sheet on the
Yeah, if you look at the current pre-calc class in chapter 5, that's what we've been doing.
No, I'm
Mr.
not even
Beamer.
kidding. Like, what's the chapter? 'Cause I don't.
Chapter 5.
Do we have to know on this test?
Can we just have a sheet of all of them?
Though on the test, they're not going to be this difficult. On the homework problems, you'll definitely see problems like this.
But so
So, like,
on the test, will we said, all right, you might make this identity.
Yes.
Okay. Because I know like sine squared plus cosine squared equals
It's
1.
that's
And if
all
it's
I
anything
know.
else,
That's all I
I do not
know.
know it.
Tangent one, tangency one, those ones are not that.
Well, that's just
all right.
changing the cosine squared plus sine squared.
Let's let us continue.
But
So what do we do here? Now we can factor. And yes, you do need to know how to factor.
Connor's gonna miss it.
So we factor that nicely. 2 cosine theta minus 1, cosine theta plus 1 equals 0. So this tells us that cosine theta equals 1/2, or cosine theta equals -1.
Yes.
What's this?
3 pi over
You on right now.
Theta equals pi, but what did we decide happens if theta equals pi?
No tangent line.
This is the pole.
That's the pole.
So it's not pi, Dylan.
Oh well.
This is at the pole. We already know there's no tangent line at the pole. So sometimes, so what this is saying is, well, there could be a horizontal tangent at the pole. We have a cusp, so there really could be, there's no determinate kind of tangent line there. It could be horizontal, could be, it may come out to be vertical also. So you have to be careful with that solution. Cosine theta equals 1/2. What does that give us? Theta equals pi over 3, and theta equals 5 pi over 3.
Maybe we need to find our needs.
And now we need to find our points of horizontal tangency. So we would plug that back in to 2 plus 2 cosine theta, and we'd find our points.
Which are obviously what you're going to give us.
3 pi over 3 and 5 pi over 3. And did we decide we should have 2 horizontal tangents?
Yes.
Yes? And if we go back to, does that make pi over 3? Theta equals pi over 3? Does that make sense? Theta equals 5 pi over 3. Does that make sense? Yeah? So it's a good idea to check to see if your answers make sense. All right, we have one more part. We have the vertical tangents. Ben, math likes you whether or not you like it. Just so you know.
Math
All right.
doesn't like anyone. Math likes to make people sad.
It's like everyone. It's not.
No, math is more indifferent. It doesn't really mind whether you like it or not.
It exists. I'm imagining maybe it's
So this one we wrote as sine theta plus sine 2 theta. So that's going to be equal to 0. I'm going to change it back to the original form we had it to solve this. So plus 2 sine theta cosine theta equals 0. And then what's our next step to solve this? Factor, yes. Sine theta times 1 plus 2 cosine theta equals 0. So sine theta equals 0, and or cosine theta equals -1/2. And this tells us theta equals 0 and pi, but this is the pole. We already looked at that one. So we need 0, and this one gives us theta equals
-4 pi.
so cosine
4 pi thirds and
4 pi thirds, 4 pi thirds, and
no, 2 pi thirds. 2 pi thirds.
there we go. Thank goodness. 4 pi thirds. So then we're going to plug this back into r equals 2 plus 2 cosine theta to get our points. Our points are 4, 0, 1, 2 pi over 3, and 1, 4 pi over 3. And we look at our graph. These were our vertical tangents. We decided we should have 3 points with vertical tangents. So let's go back. There's 4, 0. There is our 2 pi over 3. And there's our 4 pi over 3 angle. So our answers confirm our intuition. All right. Isn't that fun? All of that trigonometry. That, yeah, the test is one problem, right?
Very long problem.
The solving these trig equations on some of the homework problems is involved. I'll let you know that right up front.
How does it know? You put that in my calculator. I will find a way to create a calculator. That's actually not that hard to.
Brick it.